Okay, today we're doing the centroid, which, as a reminder, is the intersection of the medians. A median is just simply the intersection of a vertex with the midpoint of the opposite side. So what I want to do is find the midpoint of this side. To do that, I'm going to use the exact same steps that I did for finding the perpendicular bisector. Namely, start at the point, go out to more than half, but less than all the way, draw an arc up top. Second, go to the other vertex using that same distance, draw an arc, and a second arc. Now, with the perpendicular bisectors, I connected the line between these 2 points, i.e. where the points of that arc crosses and the point where the arc crosses there. Today, to find the midpoint, I don't have to draw the whole line. I can just figure out where that line would be and then draw the point on there. There's the midpoint. Cuts that into even sections. I'm going to find the midpoint for the other 2 sides. Starting at the vertex, making my distance less than the whole thing but greater than half, making 2 arcs, one up top, one down at the bottom. Going to the other vertex, same distance, arc at the bottom, arc at the top. I'm going to find the point that would be on the line between these, just like if we were doing the perpendicular bisector. So I'm going to line up my straight edge on those 2 points, find a line. All I need is that point. Last but not least, this other side. Vertex, greater than half, less than the whole thing. Arc up top, arc down bottom. Over to the other vertex, and intersect. Same point where these 2 arcs intersect. Find the point between them, where that line would imaginary cross the axis, or your leg. Again, that's the midpoint, so that cuts those into equal segments, and those into equal segments. All I have to do now is draw in the medians. Easy enough. Connect the vertex to its opposite midpoint. Vertex, opposite midpoint. Median number 1. Vertex, opposite midpoint. Lastly, vertex, opposite midpoint. And that point, where those 3 lines coincide, is your centroid.